So this is the beginning of part 2 out of 5 parts of the lecture on climate changes on Earth. NGRIP is the northern Greenland ice core, and this is a section out of that ice core from 70,000 years ago to 130,000. And this is the Eenium warm spell, which was the warm spell prior to the present warm spell that we're experiencing right now. And the bottom curve, well, these are all oxygen 18, and they're plotted so that when the line moves up, it implies a higher temperature. And these are the same thing from ocean sediment cores collected from various spots around the world. And in general, the ocean sediment estimated temperature varies along with what we saw in the Greenland ice core. Now this is the record of the Antarctic, oxygen 18 again, and this is the last glacial, the last ice age. And as you can see, the temperature is lower than what it is now, although this is just the oxygen 18 scale. And its reason it's negative numbers is that it's relative to a standard. It doesn't mean the oxygen 18 has got negative concentration. And the bottom curve here is the aluminum content, sorry, not the content, but the aluminum flux to the Antarctic ice expressed as nanograms per square centimeter per year. And the significance of that is that the Antarctic ice, where they drill this ice core, is 10,000 foot altitude. So it takes some wind to transport dust from Patagonia, which is a thin strip of land at the southern end of South America. And so most of the time during the cold spell, it was 4,000 to 6,000 nanograms accumulation rate. And then when the ice age dissipated and things warmed up, then there wasn't any more transport of aluminum to the Antarctic ice. And this is an indication, or it's more than that, it's proof that the weather was a lot stormier and windier during cold spells than it is during the warm periods. Although some people around the Gulf of Mexico are subject to hurricanes during the warm periods. Now here's another part of the Greenland Ice Project, and this URL I was fortunate to see on the internet, and I got a chance to download all this data. But I have to hasten to add that this URL no longer exists on the internet, at least. And what we're going to display in the first slide is just temperature versus time. And then we're going to overlay this record with the terrestrial dust as measured by calcium content of the ice. And then we're going to overlay insolation, which is the heat received at the latitude of Greenland from the sun. And this is the summit temperature, not summer. And this is GRIP, stands for Greenland Ice Project, which was a European funded operation. And here's the data going back 40,000 years, and this is present time. So you can see here we're starting out minus 55 or something like that, and then the temperature jumps up within just a couple of years to about minus 40 or maybe minus 39. And these kind of sudden changes, cold snaps or changes in temperature over Greenland, is undoubtedly a function of ocean currents, changes in the ocean current. And here we see it's down to minus 54 or something like that, and then it warms up pretty rapidly, and this is our present, the Holocene warm interglacial period that we're experiencing now. Now here's the scale, exponential scale for calcium, going up to 10,000 parts per million. But the highest it gets in these in the Greenland ice core is 1,000 parts per billion. And you can see when it was down here minus 55 or whatever, the dust here is around 600 or 700 ppb. And then when it warms up here, it goes down to maybe 30 or 40 ppb. And then when it dips back down here for this sudden cold snap, which lasted about 1,000 years, the calcium is back up to around 500. And every time you get a cold snap, the calcium jumps up. And here's one that lasted for about 4,000 or 5,000 years, and the calcium got up to about 900 parts per billion. And then there was some brief warm periods, and then here about 10,000 years, the calcium dust is pretty high, and it reaches almost 1,000. And then here's another 10,000 years where it stays 200 or 300, and then drops down briefly. And then here's the last cold snap before it warms up. And then when it warms up, then the calcium content varies from 5 to maybe 12 ppb. Now the people that wrote or interpreted all this data said that, well, the this is during the ice ages, so the ocean levels were 300 and 400 feet lower than they are now, so there was a lot greater area of land exposed, and they convinced themselves that that was the cause of these variations in terrestrial dust in the Greenland ice core. But that's simply not logical, because the ocean levels are not going to vary more than a millimeter in a space of 1 to 2 years, which is the onset of this particular cold snap and all the other ones. So what the burst of terrestrial dust in the Greenland ice core is, it's a measure of the drought in the northern hemisphere. So if we do anything to remove carbon dioxide from the atmosphere and trigger the next ice age, we have to behoove us to understand what causes these cold snaps, and we must know how to prevent those kind of things. And these are not something easy to change, because they're likely a change in the ocean currents. So they're kind of intractable. So let me just add the last slide here before we come to the end of part 2. But this is insulation on this same temperature plot. Insulation at the latitude of Greenland. And you can see, as it happens in all 13 terminations of ice ages in the last million years, the termination occurs at a peak in the insolation. And you can see here we're long past the maximum, and the heat received from the sun is decreasing. And that might be the cause of the fact that carbon dioxide is rising, but the temperature isn't. And that may well be because we got less heat input from the sun. So now this is the end of part